So we're now going to look at magnetic fields and get some understanding of what they are. So you may have seen, should have actually done this a wee bit in that 5, looking at the field lines around a bar magnet. And you can see how different bar magnets interact with each other as well. So these are the magnetic fields that cause that. But really, and the reason it's most useful for what we're talking about here, is that actual magnetic fields are just a special case linked to electric fields, as we'll see. So we do still have a similar idea that similar poles will repel from each other, opposite poles will attract from magnets. But where it's most useful is this idea that it's actually linked to moving charges. So you can produce a magnetic field from moving charges. So if you have a current carrying wire and you switch on that current in this example here, then you can see that these compasses, which are plotting the magnetic field, all change direction. If I reverse the direction of the supply, then you can see the arrows reverse on those compasses as well. So basically, magnetic fields and electric fields are really just two aspects of the same thing, which we now call electromagnetic fields. And that's why in the standard model, we don't have separate electric and magnetic fields. We just call it the electromagnetic force. So the force lines around a current carrying wire are actual circular. So if I look at this simulation, basically they move with the electron and it produces circular or cylindrical field lines round about that, round about an electron beam. So a magnetic field is caused by a moving charge, basically. And a moving charge produces a magnetic field in addition to its electric field. An electric charge produces an electric field, whether it's moving or still. So where are the moving charges in a permanent magnet? Well, basically, it's to do with the electrons in motion around a nuclei giving small magnetic effects. In most materials, that just all cancels out. But in some metals, for instance, iron and nickel, these small effects all coordinate together to give quite strong magnets.